Good day and welcome. I'm Mr. Simons. In this lesson number 3, we'll be looking at ungrouped data, quartiles, and how to use the quartiles to identify if we have any outliers in our data. So quartiles, we've done it in the previous box and whisker. Just to refresh, our measure of dispersion around the median. Remember, the median divides the data into two halves. The lower quartile, or quartile 1, and upper quartile, quartile 3, further subdivides the data into quarters. So we consider the following set of data: 45, 52, 85, 92, 92, 100, 110, 120, 125, 136. That's 2, 4, 6, 8, 10 data values, right? Calculate the quartiles. So for quartile 1, n plus 1 divided by 4. I have 2, 4, 6, 8, 10 values. So 10 plus 1 divided by 4 gives me 2,75. That means I have to use the second and the third value to get my quartile. So 52 plus 85 divided by 2 gives me 68.5. So that is for quartile 1, right? Also called my lower quartile, right? This is a median of the lower half of values, right? Median, or quartile 2, n plus 1 divided by 2, or I could have just said 2n plus 1 divided by 4, right? But I just want half, so I have 10 values plus 1 divided by 2 gives me 5,5. So 1, 2, 3, 4, 5, 6, 5,5 means I'm going to use the fifth and sixth value. 92 plus 100 divided by 2 equal 96. So median, this is the value that divides the data into halves. So if I put 96 there, can count 1, 2, 3, 4, 5. After 96, 1, 2, 3, 4, 5. So 96 ensures that I have 5 before and 5 after. Alright, quartile 3, 3 times n plus 1 divided by 4. So I have 10 data values. So 3 times 11 divided by 4 gives me 8,25, meaning I'm going to use the 8 and 9th value. So 2, 4, 6, 7, 8, 120 plus 125. Divided by 2, which gives me 122,5. So that's my upper quartile, or quartile 3, and this is the median of the upper half of the values. Right, now they say determine the interquartile range. So interquartile range will always be quartile 3 minus quartile 1. So from the previous slide, we got quartile 3 as 122,5 and quartile 1 as 68,5. If we subtract the 2, we're left with 54. So interquartile range, as I said, is the middlemost 50% of the data. Now, number 3, determine by calculations if there are any outliers in the set of data. So the equation for that reads, or we first find the interval, quartile 1 minus 3 over 2 times my interquartile range, and quartile 3 plus 3 over 2 times my interquartile range. So quartile 1 we subtract, quartile 3 we add, right? You can see 3 over 2 times interquartile range stays the same. So I have 68,5 minus 3 over 2 times 54, and there 122,5 plus 3 over 2 times 54. This becomes minus 12,5, and that's 203. So we look here, the smallest value there is 45. It's bigger than minus 12,5. And the maximum value is 136. It's smaller than 203. So therefore, we have no not interquartile range, we have no outlier. So all data falls within the interval, therefore there is no outliers. So for outlier, value must either be less than quartile 1 minus 3 over 2 times interquartile range, or greater than quartile 3 plus. Then we have an outlier. So in short, just to refresh, what's an outlier? We all go buy a specific item that we all enjoy, and it's 200 Rand for all of us. But somebody else decides they're going to go pay 800 for the same item we paid 200. Then we say the guy that paid 800 is an outlier. So a typical example, you'll see you buy Coke by the buy. I assume you'll know what we mean with the buy. If you go buy Coke by the buy, they charge you like 10 Rand a can. But you go buy other places, the same can, produced by the same company, same size, somehow becomes 16 Rand. So that is an outlier. Right, I hope you enjoy the lesson. God bless. Wish you nothing but the best. Please like, share, and subscribe. Bye.